Okay, this is the April 19th Math 1401 video. We're going to cover section 10.1. And 10.1 is about hypothesis testing. And I have lost my camera. So let me see if I can get it back. What happened to it? I didn't mean to lose it. Okay, we'll get the camera back here and get it going. Explain what's going on with hypothesis testing. So last subject of the class. It's kind of a, and now I've put it back. It was working just fine a second ago, and now it's completely faded. You can't even read my words, and they're in dark black on this white. I don't know if switching down here makes anything. Okay, we're back. Okay, the last subject of the class, hypothesis testing. And what happens is, it's an important subject in statistics. This is about testing statistically. Given facts. Or you could say old facts. Testing. So what happens is, I'll try to make this as plain English as I can because there's a lot of words to this, a lot of technical language to this. In fact, it's so technical, separate words. It's so technical that this entire section is just about the vocabulary. 10.1 is just about the words. So it has nothing but baby problems. Asking about the words. 10.3 next week has the full, real problems in this. But there's no way to charge into that tonight. That's why we take 2 weeks on this. Just we are subject about just the vocabulary, entire section about just the vocabulary this week. And then we finish the class with 10.3 next week with full, real problems. Really the heart and guts of this. So I'm going to try to be as plain English as I possibly can about this. In plain English. You will, given an old fact. You may have heard some of these things, like the typical family has 2.5 children, something like that. And time will pass. And someone important. Will want to know if this is still valid. That someone important is usually the government. But could be a company. Some company may want to check things out. So to test this, okay, what I should say is to find out if it's still valid, you must test it. Now, if it is still valid, we must test it. This is the point of the whole chapter. The point of the whole chapter. There's going to be a lot of words in this section and a lot of writing out words for this. Okay. That little sort of fact, typically you could call this typical wisdom, standard wisdom. Try to keep it up. Conventional wisdom. That's the phrase I'm thinking of. Conventional wisdom. Is called the null hypothesis. There are going to be three sets of words. Will be three sets of words. Type, or really should just say one, hypotheses. Second words are tests. And hypotheses, there are two types. Tests, I am doing bad tonight. Tests, there are three types. And the third kind of word is errors. There are two types. As you can see, this gets pretty involved and technical. But it's really not that hard. Okay. Let's charge into type 1 hypotheses. And again, we've said that there are two types. All right. There is the null hypothesis. It is a claim assumed to be true. So I'll just repeat my example. The typical family has 2.5 kids. Some conventional wisdom like that has 5 kids. Okay. The other type, so this is like the first, I don't call it A, there's one for first type, and then the second type is called the alternative hypothesis. It is the claim to be tested. Okay. The very first homework is going to be to write hypotheses. So how to write hypotheses. Okay. The lingo for null hypotheses is H0. The lingo or alternative hypotheses H1. Okay, I might as well just pick these out of the homework in the book. That'll be the easiest thing to do. Pick the examples right out of the homework in the book. And I'll just show you what they look like. Homework, page 434. First problem is number 9. And these are given hypotheses. And then they're going to ask you some questions about tests, which I'm about to cover in just a second. But if you take a look at this, the null and alternative hypothesis are given. Okay, this is what they look like. Maybe I went at it too quick. This is out of the book. Number 9, these are the given, and this is how you write them. They write for a null hypothesis, they write an H0 with a colon, mean equals 5. And then they write an H1, mean greater than 5. So this is your null hypothesis. This is your alternative. This is what hypotheses look like. Remember, this symbol is for mean. Null hypothesis is this H0, alternative is this H1. Okay, let's show you where they get this in the second type of words. Tests or testing. Tests, we'll say. Remember, there are 3 types of tests. All right, we'll again just number these. Let's say you're given a null hypothesis that a mean equals 50. That's the conventional wisdom. All right, what's going to happen is you are going to test this. To test this, you will perform a new survey. This is your old survey. Came up with this result. Maybe it stood for years, and now you want to see if it's still valid. test this to see if it is valid. You'll perform a new survey. You will get different results. So the question of this whole section is, are these new results? And the reason you'll get different results is you got different people in the sample. No way to collect the same old people from the old survey. Time has passed, people have scattered. You will ask different people the same question. Inevitably, you're going to get new results, different results. Are these new results statistically different from the old? This is the key question. You can word this another way. Are these new results, is the difference between the new results and the old statistically significant? That's the key word of chapter 10, significance. Key word of chapter 10. Significance. Key word of chapter 9 was confidence. Key word of chapter 10 is significance. Okay, back to my null hypothesis, mean equals 50. I test this, my new result is mean equal 40. So when I go to write my alternative hypothesis, I don't use the 40, but I read that this is less than 50, and that's how I write my alternative, mean is less than 50. You use the null number in both hypotheses. That's one of the technical things about this. You do not use the 40 here. It will be used later, like next week, when we show you where it comes in. But you do read that it's less than 50. So those are your two hypotheses. You will show the test with a bell curve. And you will shade the tail that this points to. Shade the left tail. This is pointing left. You shade the tail that points to. This is called a left tail test. Bet you had to stay awake all night thinking of that name. Well, show all three types. And by the way, only one of these types will come up in any problem. But I've got to show you in this section, I got to show you all of the cases. If you can come up less than 50 on your new result, guess what? You can come up greater than 50, right? Keep the same null. But your new result, let's say your H1, should have said H1 and put a colon there. This is a blip. Okay, let's say your new result, mean equals 60. Well, once again, you don't use the 60 here, but it's greater than 50, and that's what you put in your alternative hypothesis. That the mean is greater than 50. That's what you're going to test. Well, again, you show the test with a bell curve, and now your sign here is pointing right. That tells you to shade the right tail. Guess you'll never guess the name of this test. Right tail test. Okay, well, we said there was 3 types of tests. The third type, there will be language in the problem. In a problem, there will be language that says something like test if you are different from 50. Sometimes they use the word changed from 50. All right, so once again, your mean, your null hypothesis, mean equals 50. Alternative, if all you care about is you're different from 50, well, you could be different lower or higher, which means you're going to use a not equal. This shades both tails. They call this a 2-tail test. I haven't really stopped to ask for any questions. We've got Mr. Augustine with us tonight. Got any questions there, Mr. Augustine?
No, sir.
Okay. There's a lot of stuff to throw at you all at once. There's a few more words with this, and then we're going to talk about errors, show a few examples, and then turn you loose. And again, we'll have 2 more Zooms the rest of the week on Thursday. Okay. I'm going to try to keep these diagrams handy. And what happens is there will be language in every problem. That says test at the, they use this symbol, this is an alpha, equals. All right, numbers you might see are 0.1, 0.05, or 0.01. Level of significance. There's that significance word again. .05 is pretty standard. This is tight. This is loose. Okay. Oh, by the way, you only have one of these numbers in any problem. This is the chapter 10 numbers. Level of significance. Remember, chapter 9 was about 90, 95, or 99% confidence. Chapter 10 is about 10%, 5%, or 1% significance. This percentage whether it's 0.1, 0.05, or 0.01, is the area in the tail directly of a left tail, or right tail test. So let me call them back. Start with the left tail again. This area, if it's a left tail, has a direct alpha value, whether it's 0.1, 0.05, or 0.01, whatever they give you in the problem. That's the direct percentage in that tail. Same thing on a right tail. It's the direct percentage in that tail. But on a two-tail, your percentage is split between both tails. So you got to divide it by 2.
Okay.
But only on a two-tail, not on a left or right tail. Maybe I should say that down here. You must divide alpha by 2 on a two-tail test. All right, we now have enough, I've covered enough stuff that we can finish problem 9. That's the very first homework problem. We ready to charge into something like that?
Yes, Professor.
All right, you can see how difficult this is. See if you can handle this. Back to page 434, number 9. They give you that H0, your null hypothesis, that mean is equal to 5. Their new result, they're not telling you what it is, but it must have been bigger than 5 because they're coming up mean greater than 5. See what they're saying? They're not saying what the new result did. It must have been 6, 7, 8, who knows what it was. They're not telling you. It's just, you just know it's greater than 5. See how they're using the null number in both hypotheses. So they're just asking, first, is this a left-tailed, right-tailed, or two-tailed test? You got your multiple choice here. Have you followed any of this and want to take a stab at it?
Yeah, since it's greater than 5, it will be right tail.
Very good, outstanding. Yep, it's pointing right. This is a right tail test. Now, they also ask what parameter is being tested. This is incredibly difficult. Remember the definition of alternative. This is the claim to be tested. So what parameter is being tested? That symbol right there.
Yes.
That is what is being tested. So this one, the answer is mean. You will also see in other problems, you will see P for proportion, you might see standard deviation tested, etc. But we're pretty much going to stick to means. That's all it is. That's the parameter that's being tested. That symbol, whatever it is, right there.
Okay.
Questions about that?
Oh, this is pretty straightforward. I mean,
Right. You'll find that these are really baby problems about these words. And you'll probably wonder, what's the point? the point will be given next week in section 10.3. We will put all this together and show you the actual test. But you got to kind of sit through all this baby stuff first. Do you want to see another example of something like this?
If it's like this, then I believe I'm good. But I would love to see if when it's two-tailed. So it will be either greater than and equal to. Is that what it will be?
Looks like
Oh,
number
less than
11.
Okay.
This is off page 435. Your null is their test and standard deviation here equals 4.2. And your alternative is standard deviation not equal to 4.2. Again, your multiple choice. Is this left-tailed? Right? Or two-tailed? Want to take a stab?
I'll go since it's not less than and it's not greater than. Well, not equal to. So it might be less than or greater than. So it might fall in between. I'll say two-tailed.
Yes, it is the two-tailed. If it's less than, it'd be a left tail. If it's greater than, it's a right tail. But since it's neither one, it's this, it's a two-tailed. So then they ask what parameter is being tested. Want to take a stab?
That's the standard deviation.
Standard deviation right there. You can actually get it off of both. You're going to see the symbol in both hypotheses, but if you want to really follow this language, it's from the alternative. Should we put a whole bunch of these on the test?
Yes, please.
Okay.
Yes, please.
All right. So then we go on to the next section. It starts at 15, and now they give you a bunch of words. And they want you to write your hypotheses. Oh, and then they get into errors. So before I charge into that, I better explain the errors. Yeah, that's the third type of words. Third type of words. Errors. All right, well, there's two types of these things. Two types of errors. All right. Literally, they call it type 1 error. It is when you reject a true null hypothesis. All right. I know that's very stilted. You wonder, what the heck are we talking about? Okay, it's basically your old fact is true, but when you do the test, it leads you to reject it. I think write that down. Your old fact, that's your null hypothesis, is true, but the test we're going to perform next week, that's leads you to reject it. Leads you to reject it. So you conclude it's not true. That's called an error. I'll show you how they're going to do this in the homework. I've got some examples. I have a little demo that I try to do in the regular class, but it just doesn't translate online. There's no way I can really write it down. I sort of have to talk about it, and it just doesn't translate online too well. Okay, but I'll try to explain it out when I do some of these homework problems in the next section here.
Okay. How about the second type of error?
Well, you want to guess what the name of it is?
Error type 2.
Very good. Outstanding. Yes. It's literally called type 2 error. And it's when you fail to reject a false null hypothesis. I go through my little demo. I'm not going to do it, but basically it works off our criminal justice system. You know what our null hypothesis of our criminal justice system is? What's assumed to be true?
Oh, okay.
You're supposed to be what? Innocent until what?
We're proving guilty.
Proven guilty, really.
Yes.
Everyone's supposed to be innocent until they prove you guilty, right?
Yes.
Okay. So on a type 1 error, it's when your true null hypothesis, meaning they've charged you with something and you really aren't innocent. But you go to court, do your trial, and the jury rejects it and finds you guilty. But you're really innocent. And if you watch the newspaper, it happens on occasion. You'll read about people who finally persuaded somebody to take up their case and really prove that they're innocent. They've been in jail 20 years.
Yes.
So they've lost 20 years of their life. But somebody took up their case and finally convinced somebody important that they really were innocent, and they finally got set free, minus 20 years of their life that they can't get back.
Oh my God.
So it happens. On the type 2 error, you're really guilty. The false null hypothesis, you're guilty of sin. But you go to court and you blow a lot of smoke, and those evil police did this to you and that to you, whatever, and the jury buys it and lets you go. You probably can think of people that you knew were guilty, or at least it seems like they were guilty, but nope, they got off.
Yeah.
We won't name anybody or anything.
Yeah, I know.
Okay. But that's basically the idea, same idea. Okay, let's go to, oops, sorry about that. Let's go to problem 15, page 435. Try problem 15. So there's a lot of words to this. I'm not going to copy it all down. You can see the 3 parts. They want you to determine null and alternative hypotheses, explain what it would mean to make a type 1 error, explain what it would mean to make a type 2 error. All right, so we'll start with 15. This is about completing college. For students who first enrolled in a 2-year public institution from fall 2007, this is pretty old data, the proportion who earned a bachelor's degree within 6 years was 0.399. The president of Joliet Junior College believes the proportion of students to enroll in an institution have a higher completion rate.
Funny enough, I know that college very well.
Oh, you do? Okay.
Yes, I gained admission there.
Oh.
Yes, and before I left Illinois.
Oh, okay. Yeah, I remember it being in Illinois. Okay.
Yeah.
All right. Now, you see how you were given, and that old fact most of the time is in the past. So you see how they've reached back to fall 2007 and they cite a fact.
Yeah.
That proportion who earned a bachelor's degree was 0.399.
Yeah.
So that's in effect going to be your null hypothesis. They're going to use P for proportion. You're going to say P equals 0.399. So we're shortening up all those words in that sentence to this lingo. The proportion who earned a bachelor's degree back in fall 2007 within 6 years was 0.399. Now, the president of that college thinks that it's higher now. So notice we're not really given a new number on a survey, but if she thinks it's higher, what are we gonna put between P and 0.399?
Greater than
Greater
sign.
than, yep, greater than. Okay, this is part A, that's how it's an H1. That's how we're writing null. Look for the old fact. It's usually given first, but it doesn't have to be. Occasionally it's not. But a lot of the problems it is they start off with it. Then they say there's a new survey done. You get this result. Test at this significance if this, is a different. See, if there's a significant difference, then you might want to do something about it.
Yes.
If there's not a significant difference, it's like, oh, what the hell? Who cares? The old fact must still be valid. Okay, part B was explain a type 1 error. All right, well, I'm going to follow its definition, but I'm not going to write it exactly. Remember, it was, I'll just put it in parentheses here. It was reject a true null hypothesis. All right, so we don't really want this. They want it in the context of this. So I'm going to say it this way. And there can be different ways to say it. I'm going to say assume that P equals 0.399 is true. See, that's my null hypothesis. We want it true, but I reject it. That would be making a type 1 error.
Okay.
Okay, questions about that?
No, it's no question.
Okay. So C, when I go to explain a type 2 error, I don't know if you need me to repeat the definition. You failed to reject a false null hypothesis. It all works off, the errors all work off your null hypothesis.
Yeah.
So basically I assume my null hypothesis, P equals 0.399, is false, but I failed to reject it. That would be making a type 2 error.
Oh.
By the way, there's one other fact I should state about this while it just popped in my head. The alpha value, you might need this on the MyLab. Remember, it was either 0.1, 0.01, or these are the common, or 0.05. These were the common values. Is the probability of making the type 1 error. So in any problem, if they want it done at 0.1 significance, there's a 10% chance that your test could lead you to make the type 1 error, or a 5% chance or a 1% chance of making the type 1 error. I think when I look through the MyLab problems, I think they actually asked about this.
Okay.
So I should mention it. Do you want to see another one of this? This goes from 15 through 22. You want to see another one, or do you want ready for the next section?
I'm ready for the next session, but just to confirm, what I need to do is just to reject the probability that was given to make it a type 1.
You're rejecting a true null hypothesis.
Yes. Okay.
Right.
And
this
then
is the probability of doing that.
Okay. Yeah. Okay.
All right. Well, there's one really last section. Then there's a couple of problems with a lot of parts we can save for the last Zooms, 35 and 37. Try 23. You see how difficult this is. State Conclusions. Okay, there's two types. You see how technical this is? One, you can reject the null hypothesis. I've written it out in words. In the lingo, it's reject H0. Or number two, you can fail to reject H0. You do H0 in both types of conclusions. This would assume H0 is still valid. This would assume H0 is wrong now. If you're rejecting it and that's correct, your H0 is wrong. Conditions have changed. It's no longer valid. It's not valid. But if you fail to reject it and that's correct, then you're assuming it's still valid because you're not rejecting it. All right, so try 23. It says for the hypotheses in problem 25, I'm sorry, problem 15. For the hypotheses in problem 15, the null hypothesis is rejected. That's what's given. Null hypothesis is rejected. They say state the conclusion. It's one of these two phrases. Do you want to take a stab at which one it'll be?
So it will be the first one.
Yep.
Yes.
Yep. Answer. Reject the null hypothesis. It's almost like going in circles, like they've given you the answer in the problem, you know? But hey, I didn't write the book. You see how babyish this is?
Yes.
Okay. Well, enjoy some easy problems while they last. Okay. Do you want that last from 23 to 33?
No, I'm good right now.
You're good. Okay.
Yeah.
Well, there's, like I say, a couple of others, but we could save those. They kind of put everything together, and we could save those for Thursday Zooms or whatever if you want to. You think you've seen enough?
Yes, sir. Yes, Professor.
All right. Well, I appreciate you coming out tonight.
Thank you, Professor. Will you give us the MyLab problems to solve on 10.1?
Yeah, I mailed them out.
Oh, okay.
And they're posted in D2L, yes.
Okay, thank you.
Yep. Oh, and I'm going to mail out the final exam review sheet on Wednesday too. So everybody has at least a week to look at it. Yeah, next week it's, next week's the last week of the class.
Okay, just to clarify, we will have one more test before the final exam.
That's right.
Oh,
Next week, this week is a quiz on 10.1.
okay.
Next week is your test, last test of the class. It'll cover 8.1, 9.2, and 10.1 and 10.3. Week after that, final exam, and we're done.
Okay, thank you.
I know that breaks your heart. Try not to shed too many tears.
Thank you so much. Thank you.
Okay, sure thing. You have a good night. We'll have a 12 o'clock and 8 o'clock Zoom on Thursday.
Thursday, yes. Thank you.
Okay,
Appreciate
sure thing.
it.
You have a good night.
Good night, sir. Bye.
Okay.